Hello and welcome back. It is time once again to try to fix something. And today on the workbench, as you can see, I have a PS4 Pro that is supposed to be no power. Well, I think it is anyway. I kind of can't remember. Or maybe it was just an unknown. Let's plug it in and give it a try though. Can't remember. Okay. Let's see. Eject. We beep. We have standby power. Power. Blue light, and we shut off very quickly. And we won't do anything else. Huh. Unless I unplug this and plug it back in. So maybe we have a dead supply. The 12 volts is not coming up. Try the eject. Power. We get about one flash and we cut off. Alright, so let's get this open and I will try a spare supply I think I have laying around here somewhere. We'll give that a try and see if that's the issue. Also, just noticed it looks like the security tape is still in place. Has not been opened. HDMI port looks pretty good. So maybe this one is unmolested. Well, it looks to be a little liquid damage here. Look at the bottom of the case. And I think we've got some insect damage going on there. So yeah, a dead power supply is not out of the question. Well, after searching through my parts, I didn't find a, this is a 300 FR, and I found some of the other ones, the CR or ERs, but not this exact one that has the round pins. So I guess the only thing to do is take this thing into the workbench and we'll put it on a load and enable it and just see if the 12 volts comes up or not. That's all I can do at this point. So let's get it inside. Alright, we are inside of the workbench. And I have the leads connected to my DC load here. AC power is going into it from my isolation transformer. We know we had 5 volt standby because it was, beeping, trying to eject and turn on. So I'm going to enable the 12 volts now with this little. I've got the jumper between pins 1 and 3, which is between 5 volt standby and the AC DC enable, I think they call it. You can look down in there. I can't remember what they call it. Yeah, so it's the third pin. We're putting 5 volts in there should enable the supply to put out 12 volts. If I get it turned the right way, let's see what happens. Nothing happened. Absolutely smurfly nothing. Okay. So, well, that's good news, I suppose. That means you probably just have a power supply problem to work out with the 12 volts. Well, that's much better than a main board problem, in my opinion. So let me get this thing open and see what's going on with it. Alright, we've got the supply open, and this is what I don't recommend you do if you're not familiar with working on these things, because they can hurt you. There are dangerous voltages in here. Even when it's unplugged, these capacitors there can hold a nice jolt. But we've had, as I disassembled, there's been a few evictions. You can see there's one. There's one, and there's one over there still in the case. So I think we're going to find, oh, yep, look on that bottom lid. See that little scorch mark right there? So I think if we flip this over, we'll get an idea where our issue is. Okay, there's one stuck there, but I think our issue happened right in there. Right in there. So what did we burn when we decided to crawl across there? What is this chip? See if I can get it just the right angle. Oh, DAP 49. I think I have those. I think I do have those. Probably going to need one because I have a feeling it shorted something it shouldn't have and probably popped that chip. Well, let me get set up a little bit better. Maybe we'll do some more troubleshooting on this thing. Alright, I already brushed the dead roach off, but you can see another little arc spot right there at the end of that resistor. So we may have an issue there. Yep. Alright, I think I got the microscope set up. I'm ready to take a look at this area right in there where we have some carnage. And there you can see that DAP49. And if you look, looks like over here where we saw that burn mark, I do believe we've blown a trace off the board right through here. So we'll have to fix that. I'm kind of curious where that went. It looks like it traveled under this resistor to ground. Is that ground? I see a common bus across there. Let's just see if that's ground. Because if it's shorted to ground, maybe it didn't do too much damage. If it's shorted to an IC, shorted some high voltage to an IC, then we got a different set of problems. Let me go right here a second. Let's see. Oh, I'm not sure why yeah. That's the negative terminal of the main filter cap right there. Also looks like there's some corrosion under the solder mask there. So, oh, it was ground, so the ground's gone now. That's the issue, isn't it? I'm checking for ground, relative to that negative terminal, that large filter cap. And it's not going to be there because it's burned open. That's exactly what's burned open. That went under here, around here, and was, the ground for this array of resistors and capacitors connected to the DAP49 right there. So that's why we have no 12 volts. Our controller IC for the 12 volts is not getting a ground. We would be very lucky indeed if all we did was blow a trace off the board right there. Very lucky. Well, I have not tried to power it on yet, but I just did a few quick checks around the board, some Zeners and some ICs, and I think we have other issues to work out. It's not going to be as simple as just a jumper. Let me show you under the microscope what I'm looking at. Right. Of course, there's that DAP49. Pin This is 8, 9. Pin 10 is ground. And right here you can see a Zener J3. Gotta look that one up. I can't remember. I think it may be like an 18 volt Zener. Can't remember. I'll look it up. But that is across the supply voltage. You can see it going right back here to, let's see, is it 10? Yeah. No, 10 is VCC and 11 is ground. 8, 9, 10, 11. So this end's ground. Or am I backwards again? 10 is VCC. 10 is VCC. 11 is ground. That makes sense. So this is ground. This is VCC. I thought this was across the VCC, but it's not. It's going to be across this pin right here, which is one of the outputs. Let me get it back in the frame. I hate this lens adapter. You can see that Zener. This one is connected, the anode is ground and the cathode is connected to pin 9, 10, 11, 12. And pin 12 is the lower MOSFET driver. Should go to the gate of the lower side MOSFET. But this MOSFET, I mean, this Zener seems fine, totally fine. Yeah, 0.587 forward, she's fine. This one beside it, though, is shorted. And I'm trying to figure out where this one connects to. I can't remember. Of course, it's getting ground here, but it runs around the world. So this one seems good, but whatever this one is doing, it's no longer doing its job. Let's see if we can follow it around the world here. Cathode. We're going back this way and we're going this way. Okay, we're going two different directions. Is this the one that's on the supply one? ZD31? Because it looks like the way it's going, if I can keep all this in frame for you. Right through here, 0 ohm jumper. Yeah. And this goes on, I think, to the top side of the board. I can show you in a minute. But you can see this side of it, right around through here, under this 0 ohm jumper, to a capacitor here. And you can see it continuing on under the IC. And if I'm not mistaken, what it's doing is coming up to pin 10. Yes, so this is the one across the supply voltage. And it has died. So that means our, what is it, 13 volts, 15 volts supply voltage to this IC apparently went really high and caused this thing to die. And if that supply voltage went high, then several other things could have died also, because there's several ICs running off of that voltage. Like if you see down through here, I got lost again, right under here, through here, right there, through the 0 ohm jumper, and we go up to the top side of the board, as I'm looking at it anyway, right through there. And if I don't lose track of it, it goes under that diode. Oh, you can see it barely there. I think it's going right there. And I'll bet you that, see, that's the 1612A3, that is the power factor corrector IC. Let me just put my meter on it. Yes. Yeah, that's in parallel with the VCC on the DAP49. So we may have lost this one, we may have lost this one, and whatever else is on that supply voltage. Alright, well, we have a short across ZD31, but is it the Zener itself, or is it, one of the ICs just intended to protect? Let's find out. I have lifted one end of that Zener. So is the Zener itself shorted? Nope. The Zener is still good. So I'm going to say the Zener failed terribly at its job. Zener is fine. So something on the supply chain is bad. Could be the DAP49, which the supply goes in on pin 10. Let's see, where is it? I'm trying to remember. All right, right there. See this zero? We can lift this 0 ohm jumper, and that should isolate it from the power factor corrector, and that should tell us in a hurry if it's one or both. So let's do that. I'm going to use a little low melt. Of course, it is still glued down, so we're going to have to pry it up. But I'm trying not to hurt it, of course. There we go. Now let's let it sit to the side there. All right, now we have isolated the supply voltage going up to the power factor corrector. That's 1612A3. So do we still have a short to ground? Let's see, this happens to be ground, and we were shorted right here. Yes, we do. So we are still shorted on pin 10. But if we look at this, it's going on someplace else also. It's going under this. Oh, is that the right one? Yeah, it went two ways. It went up to the top of the board, which we isolated, but it also goes further to the right. Right down through here, right over here. This is going to be hard to track because they get real close together, and I believe we're the top one here. Now we're not the top one. Under these 0 ohm jumpers. Right over to this side, around, around, around. Oh, another 0 ohm jumper. So there's a place to isolate it if we need to. A convenient place. Better than cutting tracks anyway, cutting traces. Then we come up through here, another 0 ohm jumper. Up through here. Now it's going to be getting hard to kind of see where it's going. Which one is it when it comes out the other side here? I don't know. Alright, let me put my meter on the contact over here under that Zener diode we were checking. Is it here? Yes. So it's right there, this ferrite bead, which is connected to this. Not sure what that is. Although it does look familiar, I can't remember where it's going. Should be going to a diode. Oh, my meter went to sleep. It was tired of all this. No, wait a minute. I'm in diode mode, and that's reading 0.028, which is not a dead short. Let's go to continuity mode. Let's just see, because that supply voltage should be leading to a supply that's generated over here off the back side of the one of these transformers over here. That's where it's generated. It's not the 12 volts that goes out. It's a separate supply on the hot side of this thing, not the cold side. All right, that's 57 ohms. That's not where it's going exactly. That's 0 ohms. So it's going right to this jumper. That's 0 ohms. It goes over here, around the world. Okay, I know what this is. This is that ZEW. That's just a transistor, a bipolar transistor. I think it's a PNP, and that is the switch. That switches the supply voltage to those other ICs. But that doesn't really have a path to ground, if you know what I mean. Like, no leg on this thing is tied hard to ground. So even if it's shorted every way it has, it couldn't give you a dead short to ground. So that's probably not our issue. That's where it's come from. This just shows you where it's coming from, is this IC. It's switched and goes back to the other side of the board where we just were. So I don't think that's our issue, because that couldn't short us to ground. Let me go back to continuity over here. And we are still shorted to ground, aren't we? No, we're 56 ohms from ground now. 56 ohms. So did that change after we lifted this jumper? If I go to that point, this goes on up to that IC we isolated. It's wide open. So I'd say that power factor corrector is not shorted. That's not what's shorted. If the Zener's not shorted, $57 ohms. I thought we had a short there, but that's not a dead short. What's going on here? Well, let me show you what I've done now. I have lifted pin 10 of that DAP 49, the VCC pin. Let's just see if that's where our 50-something odd ohm load to ground is going. Let's see. Let me find ground is here. All right, now I'm 55k ohms and 57 on that VCC of that chip. So I'm pretty sure that chip is bad. So we'll go ahead and replace that, and I think we'll be ready to test at that point. Need to remember to tack the Zener back down. It's not hurt. So yeah, I think that's our issue. Alright, I've replaced the DAP 49. We've fixed that, burned open trace. I put those 0 ohm jumpers back in place, soldered that Zener diode, back down that I had lifted one leg of. And we're ready to test. Now, I don't know for sure if the power factor corrector IC has survived. The IC we replaced is for generating the 12 volts, but that power factor corrector has to also work. And it's on that same supply voltage. So it's not shorted though. Not shorted, but it doesn't mean it works. So I've got my load set up over there. Let's see. I've got the AC on. Let's see what happens. I guess you might want to see that. Well, I heard a noise. I don't think she's working. We still haven't found it all then. Keep looking. Well, this repair went on for several days with me, when I had time, working on it, chasing various suspicious looking readings. Like this Zener diode was it's across an opto-isolator, part of the feedback circuit for the 12 volt supply, and it turned out to be shorted. So I had to find a donor one out of another another board I had laying around, and I did that just to figure out what the Zener voltage was of a working one in that circuit. So here I am applying a 10 milliamp maximum current, and increasing the voltage slowly till I see that Zener diode start conducting. So then I know what its Zener point was, which turns out to be about 9.1 volts. And which luckily happens to be something I have on hand that's used in some of these supplies. So that was not hard to find. But it looks like it turned out the opto-isolator was fine. It was not I wasn't sure which one it was, but the opto-isolator itself seemed to test fine. I did not replace it. But there were, I had to isolate it to figure it out. That's why you see things lifted everywhere. That's me trying to chase issues. But those 0 ohm jumpers are very convenient for lifting and isolating different parts of the circuit. Make it very convenient. Otherwise, you got to cut traces to figure out, which one it is. But just putting those back down, and then I realized a lot of that was low melt solder, which is not something you really want to leave on the board and trust to hold a component down, because it gets liquid fairly at a low temperature, and these supplies can run warm. So replace that with some good leaded solder, and we should be good to go. But yeah, and at that point we were ready to test, and I was highly optimistic that it was going to work. Apply the enable line to it with my little handy dandy jumper wire, and we are met with disappointment again. So more chasing around the board looking for odd reading. There's a negative temperature coefficient resistor, which I was suspecting because there was a real low reading there, but turned out that was not the problem, thankfully, because I did not have any of those particular resistors. It's kind of a specialty thing. I isolated here. Again, those 0 ohm jumpers, very handy for isolating different parts of this circuit. So I just have to lift it and then go back and figure out where my low resistance reading was. And it was not that NTC, luckily. Oh, all good. So I finally came to the conclusion, after following where that went, where there was a low resistance reading, but it wasn't that. It went into the DAP49. Again, another 0 ohm jumper there to get there. But this was a type of feedback. This was the over temperature shutdown into that DAP49. And I wasn't sure, wasn't convinced yet, so I'm lifting capacitors. It can be anything on the circuit, especially if something if high voltage has been places it should not be, you really can't trust anything. So just lift that out of the way, and no, that was fine. That wasn't the issue. So it didn't leave much on that circuit. There was like one resistor left connected, and the chip itself, which I had already replaced. So, but we have to lift that chip. That's why we lift that pin where it goes into that IC. And then it was like a 12.5 ohm measurement to ground. That was magically gone when I lifted that pin of that DAP49. So apparently the DAP49 went bad or was bad, because that's 12.5 ohms into that thing. And I'm not sure if that bad Zener caused that to fail, because that Zener on one of the feedback signals was bad. It was shorted though, because it looked like seems like that would limit the voltage to little to nothing. But I'm assuming that bad Zener diode that I replaced caused the failure of this DAP49 again. So we had to replace it again, and then we will be ready to test one more time. Well, I am long overdue for some good luck on this one. Hasn't been that way so far. We are ready to test. The load is on. Let's get some AC power into it. And please work this time. I'm tired of working on you. Let's see what happens. I'm going to jumper it down here. Well, if I can line that up. There we go. Finally. So I must have somehow damaged that DA5059, or the bad Zener, that wasn't working. Must have caused some damage to it, because it was bad. I've only got one of those left. I've got some on order though. But there you have it. So let's get this back in the housing and see if that PS4 Pro works. We are back out in the garage and ready to test this power supply, which I hope very much was the only issue with this PlayStation. We have power in, we have HDMI connected because I am optimistic. We have a flashing blue light, we have a fan spinning, which I love to see, and I think we have a monitor trying to lock. Probably unhappy about the state of its hard drive storage system right now, but maybe it'll be happy here in a moment. But I have good feelings on this one. I'm sorry this one took so long, kind of went on, but I did want to show that they're not always simple, and I'm very lucky that that I can spend the time to work on these things, because this is a hobby to me, and I can't really afford to replace these supplies every time I find a bad one. I need to fix them, and I enjoy fixing them. I enjoy working on them. It's a challenge, but it's not always quick. And this one took it's been like 3 days of off and on working on it. I would like to see it give me the logo though. Give me a good white light and a logo, and I'll be happy. Or don't. She's going to come up. She's just taking her sweet time. Oh, saw it for a moment. Okay, there it goes. All right, we're doing a system storage check. So we are in good shape, I do believe. This thing is still nasty. It's still lots of the power supply is clean now, but the rest of it is not clean, and it has to have the roach parts removed. But I think that's going to be the end of this one. I appreciate you hanging in there with me for this one. If you enjoyed that one at all, thought it was entertaining or educational, please give me a thumbs up, and I will see you in the very next repair, which hopefully should be a PS5, which is sitting in that box right over there. Parts are in for that one. So I will see you then. So long for now.